Hello everyone, welcome back to the revision series of UGC NET Electronic Science. So in this video we are going to learn about D flip-flop, the second type of flip-flop which is called as D flip-flop. Okay, if you are first time to my channel, please consider subscribing and don't forget to hit the bell icon to get video notifications from my channel. Right, so D flip-flop stands for delay flip-flop. Okay, so D flip-flop stands for delay flip-flop. So the important point which you have to remember is D flip-flop is modification of SR flip-flop designed to eliminate, it is designed to eliminate the indeterminate condition in SR flip-flop. It is obtained by complementing S and R inputs. Okay, so this is very important point. So D flip-flop is modification of SR flip-flop designed to eliminate the indeterminate condition, and it is obtained by complementing S and R inputs. That means, so if you have given with S and R, that is SR flip-flop, this is clock pulse Q and Q bar. If you are given with SR flip-flop, you can design D flip-flop from SR flip-flop. So by complementing S and R inputs. Like this. So this input is D input. Now this SR flip-flop will act as D flip-flop. Okay, so by complementing, so one single input NAND gate, we know that it acts as NOT gate. Single input NAND gate will act as NOT gate. Okay, so because when you give for NAND gate, if you are giving single input means you are tying the same input. So here A, if you have given, so this will be A into A whole bar, so this becomes A bar. A into A is again A, so it becomes A bar. So single input NAND gate will act as NOT gate. So S and R inputs are complement to each other. Okay, so when D is equal to 0, what happens when D is equal to 0? So this same input is applied here, so that means S is equal to 0, and this is NOT gate as I have told you, so R becomes 1 because D is equal to 0. NOT gate, when it is passed to NOT gate, it becomes 1, so R is equal to 1. When S is equal to 0 and R is equal to 1, we have already seen in SR flip-flop Qn plus 1 is equal to 0 because it is reset condition, because R is made equal to 1. Similarly, when D is equal to 1, when you are giving D is equal to 1, so in this case S is equal to 1 and R is equal to 0, so Qn plus 1 is equal to 1. So whatever the value of D you are giving, you are getting the same value at Qn plus 1. Okay, so this is called as delay flip-flop. So the truth table, if you want to write the truth table, so how can you write the truth table? D and Qn plus 1. So if you give D as 0, you are getting Qn plus 1 as 0. When you give D as 1, then you are getting Qn plus 1 value also 1. So what will be the characteristic equation? So characteristic equation is Qn plus 1 is equal to D. So this is the characteristic equation of D flip-flop. If you want to write the excitation table of D flip-flop, so as I've told you, so first of all you have to write Qn plus 1. So 0 0 0 1 1 0 1 1. Okay, so the truth table, the characteristic equation is D is equal to Qn plus 1. So we'll get the same values as Qn plus 1, 0, 1, 0, 1. Okay, so this is how you can write the excitation table, and this is the characteristic equation, and this is the truth table, and this is the explanation of D flip-flop. Okay, so in this D flip-flop we will never get the condition S is equal to 1 and R is equal to 1. So this condition is eliminated. This condition is eliminated. So that is what I have told you, to eliminate the indeterminate condition. Eliminate the indeterminate condition. Also this condition S is equal to 0 and R is equal to 0, this condition can also be eliminated, because when S is equal to 0 and R is equal to 0, then Qn plus 1 is equal to Qn only. There is no change. There is no change. When there is no change in the output, this condition is also not desirable. So this condition can also be eliminated in the case of D flip-flop. So this condition never arises, and this indeterminate condition also never arises. Only the output may change from 0 to 1 or from 1 to 0 based on the D input. Okay, so this is the advantage, or this is the modification of D flip-flop over SR flip-flop. Okay.